Today we're talking about section 4.3 on conversion between number bases. As we have talked about in expanded form, in the Hindu-Arabic system we have base 10 numbers. So what we find with a base 10 system is that we have 10 distinct symbols. In our case it's the symbols 0 through 9. And then the positions of the symbols represent the powers of 10. For example, you can see 891,253 below. Not only do we have the 9, or rather 10 distinct symbols, but each place represents a power of 10. So, and it increases as we go to the left. So if we remember how we use our base 10 system, it becomes fairly simple to talk about a system in another base. So if we're talking about a base 5 system, base 5 will use 5 distinct symbols, and those are 0 through 4, and the positions represent powers of 5. So in base 5 you won't see a 7, you won't see a 9 used. You're only going to find 0 through 4 used. Notice how we indicate base 5. I have seen little numbers, a subscript as the subscript rather than the word. In our textbook I believe they use the word, so yes, they do. And so that's what we have here. So that's the method I will stick to. So if we look at this number 14302 in base 5, notice I'm not reading that as 14,302, because when I start say thousand and hundreds, that's base 10. So 14302 base 5. What it means is we have we have 1 5 to the 4th, we have 4 5 to the 3rds, 3 5 squares, 0 5, and remember 5 to the 0 is 1, so we have 2 1s. So 1 times 5 to the 4th is 625, 4 times 125 is 500, 3 times 25 is 75, 0 times 5 is 0, and 2 times 1 is 2. And so the base 10 equivalent of 14302 in base 5 is 1202. Okay, so let's consider base 3. How many distinct symbols would be needed for base 3? Okay, a reminder. For base 10 we needed 10. For base 5 we needed 5. So what do we need for base 3? Right, we need 3 distinct symbols. Those symbols would be 0, 1, and 2. So we have 3 symbols. The positions would represent powers of what number? It would be powers of 3. So if we want to convert 2011 to its base 10 equivalent, okay, and we're working in base 3, alright, the first thing I like to do is put in my powers of 3, just like I did. So I have 2 times 3 to the 3rd, plus, there are no 3 squares, so I'm going to leave that out. 1 times 3 to the 1 is a 3, plus 1, and that's a 0 there. It might be a little bit hard. 1 times 3 to the 0 is a 1. So we have 27 times 2 plus 3 plus 1, so that's 54 plus 4 is 58. Okay, so we have 2 times 27, 1 times 3 is 3, and 1 times 1 is 1. So 54, and then what I did was combine these two to get a 4. Okay, so next step is we have 2 more bases, base 7 and base 2. See if you can convert those into the base 10 equivalent. Remember, in base 7 you want powers of 7 In base 2, you want powers of 2. So go ahead and pause the recording and see if you can figure those out. When we come back, we'll take a look at the answers and see if you are correct. Okay, hopefully you have an answer now for these. And I will tell you, I usually get out my calculator when I get these larger numbers. 7 squared, 7 cubed, and 7 fourths. So what we have is 3 times 7 to the 4th plus 6 times 7 cubed plus 5 times 7 squared plus 2 times 7, and this is going to be 4 ones, so I'm just going to write it as a 4. That's going to be a 14. Let's see, 7 raised to the 4th power. So we have 3 times 2401. I'm just going to do these in a column and it'll make them easier to add. 7203. We have 6 times 7 cubed is 343. So 6 times that is 2058. Alright, 5 times 49. That's 245. Okay, and I had the 14 and the 4. So I think I'm just going to stick with my calculator. 7203 plus 2058 plus 245 plus 14 plus 4. Okay, I'm coming up with 9,524. 9,524 for that one. Okay, so basically I changed it into a vertical column to make it easier to add, and then I ended up using my calculator after all. Okay. And then the 14 and the 4. So, alright, what about the base 2 number? Maybe I can do that one without my calculator. 2 to the 1, 2 squared, 2 cubed, 2 to the 4th, 2 to the 5th, 2 to the 6th, and 2 to the 7th. So we have 1 times 2 to the 7th plus 1 times 2 to the 4th plus 1 times 2 to the 3rd plus 1 times 2 and plus 1. Okay, 2 to the 7th I believe is 128. I'm going to double check it. Yeah. So we have 128 plus 16 plus 8 plus 2 plus 1. Alright, so I'm going to take 128 plus 16 plus 8 plus 2 plus 1. 155. Okay, now sometimes we do have bases larger than base 10. For example, in computers, very often they work with binary, octal, and also hexadecimal, base 16. And so what I have here is listed the base 16 symbols. For base 16, we would need 16 symbols to represent that particular base. And so notice when we get to 10 that we use the symbol A to represent 10. For 11 we use B, for 12 we use C, for 13 we use D, for 14 E, and for 15 we use F. So the question is, what does 5AE6 base 16 equal in base 10? Well, we do it the same way. This is 16 to the 0, 16 to the 1, 16 squared, 16 cubed. And what we do is we take 5 times 16 cubed, that's going to give us 20,480, 10 times 16 squared, 14 times 16, and then we have our 6. And that gives us the final result, which in base 10 would be 23,270. Okay, now it says to convert 1BC2 base 16 into base 10. So pause the recording and see if you can convert that into a base 10 number. And once you have your answer, go ahead and restart the recording and we'll check your work to see if you're correct. Okay, let's look at this one. We have 16 to the 0, 16 to the 1, 16 squared, 16 cubed. So we have 1 times 16 cubed plus our B represents 11. Our C represents 12. And 2 times 1 is going to be 2. So 16 cubed is 4,096 plus 16 squared is 256 times 11, 2816. 12 times 16 is 192 plus 2. I'm getting 7,106. Hopefully I didn't hit any wrong keys or compute anything incorrectly. 4,096, 28, 16, 192, and 2. Now, at one time the textbook talked about a calculator shortcut. Let me see if that is... Yeah, I would recommend that you not use the calculator shortcut, okay, because I find it's confusing, and usually whatever's confusing for me is more confusing for students. So I do recommend that you just skip over that. If you're doing problems in the book or anywhere and it says to use the calculator shortcut, just ignore it and go ahead and use the method we've used here. Now, the other thing we have to do, we've practiced going from another base into base 10.